Hello viewers, I am with a new topic today that will be amine Boc protection. So suppose you have a primary amine, so how to protect this amine group with the Boc group. So why we have to do this Boc protection? So this is Boc protection actually can be done by using ditertiary butyl carbonate. So if I draw the structure of that compound, so here you can see so this is called Boc anhydride or ditertiary butyl dicarbonate. So suppose you have this amine group in a molecule and you want to do functionalization of other part. So somewhere in the molecule, like suppose there will be another part of the molecule and you have the amine and you want to take this, maybe you might have some other group or whatever, but you want to take this alpha proton with the carbonyl group that is more acidic. So you want to remove this proton, one of the proton from here, to make a double bond here, and after that you want to quench with like different material like TMS chloride or something, so to make the TMS enol ether. So you can use LDA, like lithium diisopropyl amide. So LDA is a kind of base and it is sensitive, so you can abstract this proton by using LDA. But if you want to use LDA, you have to protect this amine group with the Boc protection. So remember one thing, LDA normally take like to do the next step, like to abstract this proton by LDA, you have to use little bit excess LDA, because even if you protect the amine group here like nitrogen and H, and Boc protection will be like this. So this is your Boc protected group. This part is called Boc protected group. So this is still, this amine will have one more proton. So if you do the LDA reaction, some LDA also will be remove this hydrogen, but after quenching the reaction the hydrogen will come back. That's why these kind of reactions take little bit excess LDA, like 2 equivalent. That's why people use 2 equivalent, like when they have something like this and they want to do the LDA reaction to remove one proton from here, so they use 2 equivalent of the LDA. Okay, so that is different chemistry, but now we are talking about the Boc protection of this amine. So how you are protecting the amine by Boc protection, what is the mechanism? So when you have the amine, it will use its lone pair electron to attack the nucleophilic attack, and once it is attacked, then this bond will break down, and ultimately you will get two part. One part is like that part, and another part will be your R and H, and it will be plus since it attached with the carbonyl group. And since in this reaction you have to use a base, so use the base. Normally base can be used diisopropyl ethyl amine or triethyl amine, or sometimes you can also use potassium carbonate So that base will take one proton from here, and that bond will come to this nitrogen to make it neutralize nitrogen. So ultimately you will get R and H, this Boc protected. So this is the product. On the other hand, this byproduct will go to this here, and that bond will break down, so to give you the carbon dioxide gas, plus you will get T-butoxide. So the T-butoxide will form like T-butanol, and carbon dioxide is gas. So finally your Boc protection reaction can be neutralized with sodium bicarbonate. So in that case, the whole reaction will be in the basic system. So your Boc protected amine can be extracted with the ethyl acetate or dichloromethane. So let's see how I'm going to set up this reaction, and then you will understand how to set up this Boc protection. It's a very simple reaction, but it is very important tool in many cases, because you can protect amine not to react with other reagent while you are treating the other functional group with other reagents. So let's see how I'm setting the reaction. So here you seeing the container of ditertiary butyl dicarbonate like Boc anhydride bottle. So I'm measuring this reagent for 1 equivalent. So you see it is a kind of solid, but it is low melting solid. So even sometimes if it is exposed to air or like with the metallic spatula, it start melting. So it's okay. While you are adding whatever this amount are solid, you can add. So here I am taking the solvent tetrahydrofuran like THF. So I'm going to add this solvent to add the Boc anhydride in my reaction flask. And while I'm using the paper, some of this may be dissolved, so I'll take the solvent and I'll use some of the solvent to dissolve to wash out my dissolved Boc anhydride in the paper. So here I'm taking the THF solvent from here. First I'm just flashing the syringe with the gas. So I will insert the needle a little bit, and then I will just remove the air, and then like normally I do 3 times. So do not take the solvent directly from the bottle, like at least do 2 or 3 times of air flashing and gas flashing. So I am taking the required amount of the solvent, but I will not use all of that solvent for washing purpose, like for taking the Boc from my paper. So here you are seeing that my weighing paper had like some dissolved or like melted Boc anhydride. So I'm just trying to washing out, and then I will remove this paper and I will put the rubber septa quickly, and the remaining solvent I will use for other purpose, because my amine compound is kind of sticky, like it is not solid. So I measured in a small vial. So, and again here I'm using the base as a potassium carbonate that was kept in the oven for overnight, and then I did like vacuum degassing, and now it is ready. So I'm going to use my required amount of the potassium carbonate base here, but in many cases people use some other bases, but for my reaction I'm using potassium carbonate. So here I'm going to add the potassium carbonate quickly, and then I'll do like quick degassing here. Maybe I'm not showing how to degassing, like just use the double manifold. You already have seen my many of our previous reactions. So here now my amine compound is in the vial. So with the gas attached, I added some part of the solvent and dissolved it, not all of the solvent, dissolve it, and now I'm transferring my compound in THF with another syringe while the solvent syringe is attached there. So um, it is easy to take with the by using two hands. Since I'm recording, so I was using one hand here, but yeah, it is tricky. So I'm quickly attaching my amine with the like THF, dissolve in THF. So I will do like 2-3 times same way. So I will add the solvent inside the vial from the other syringe, and then I will rinse the vial with that solvent. And once it is rinsed out, then I will take out that part again. And remember, I am using here the cap with a rubber septa so that I can poke my syringe needle through that septa. So here I'm just taking my compound like amine here. So so once all of the compound like amine is added there, and first remember like I added the Boc anhydride, and then I washed out little with little bit THF, and then I added potassium carbonate, then I did degas. Now here in this vial I added THF in my amine compound and I dissolved it, and now I am taking with another syringe needle. Now I'm adding the compound in my flask, and once all the compounds are added here, then I will quickly remove my rubber septa. So here I'm using like third time wash to make sure that all of my compound get washed out. And now I will remove the solvent syringe from here, and I will do range from this, and I'm going to use the same syringe to take out the final washed THF containing trace amount of the amine. So once it is done, then I'm going to remove the rubber septa from my reaction flask, and then I will going to attach a condenser. And make sure that before attaching condenser, put some grease in the joint of the condenser so that after heating it cannot start with the flask. And here under gas I am taking this, and while I'm taking, so I am also taking some gas so that since I am transferring, so it will not be air contaminated. Now I'm transferring my gas line on the flask, and then I will add the remaining part of my amine. So as I was saying, after addition of all of those, then I will do quickly degas, like just quick degas, not like continuous degas, like movie rotation of the like knob 1 or 2 times. Then I had a condenser in the oven for overnight, so now I have attached the condenser with a grease and also rubber septa attachment. And after attaching the rubber septa, then just invert the rubber septa like this, as I am doing. So be careful with the needle, definitely. So once everything is attached, make sure that these joints are like tightly connected, and I put grease in the joint so I can rotate the condenser. And then I will add the water, that water tubing also connected with the clip so that it cannot propelled out from that condenser. And you can see the gas is on. So now gas line is on, and I'm going to start water. And once everything is fine, then I'm going to add the heating source. So here I put the heating source with the sand bath. So my reaction flask is kept under the sand, and now I started the stirring. And so when everything is done, set up part, then you can start heating. But make sure that before heating you have to do a couple of things. If you use the probe, so make sure that you are attaching the probe, otherwise your hot stirring plate will show error. And then make sure that all the plastic tubing or like wire, everything away from the heating source. And then start water in the, like here I'm using CW, means cold water, so I'm starting cold water through the condenser, and then I will start heating. And also while you are starting heating, make sure that you are keeping all other organic solvent, squirting bottle or any solvent away from the heating source. All tubing, rubber system are away from the heating source. So here I have kept all the tubing away from the heating source. And finally, when everything is correctly done, then I will start heating, and also I will remove my solvent bottles and other things. So here I'm showing the clip to connect the tubing so that it cannot come out from the condenser with the force of the water. So it happens sometimes, so you have to be a little careful while you are doing that. So now this is the reaction setup. So I will continue this reaction at 80 degrees Celsius for overnight, like normally around 12 hours. So once everything is done, so I'm making sure like all things are okay. And here the system you can use 4 more reaction, but here I'm not doing 4 more reaction, just 1 reaction. And all the solvent bottles away, as I was saying. And also the temperature now, so water is on, and everything is set up perfectly. Now I'm going to start heating for this reaction, and heating probe is also attached. All the tubing, rubber tubing or like wire is away from the heating source, otherwise those will melt down. And that could be very dangerous, or safety issue, potentially dangerous. So I'm just removing or making away, and now heating. So I started heating, and I will fix the temperature as a 80. So it will slowly start increasing at 80 degrees Celsius. So once the reaction is started, and I will keep monitoring until the temperature goes up to 80 degrees Celsius. So here I'm monitoring the temperature, and it will increase to 80 degree. And make sure that the flask is surrounded by the sand, so that it can get the homogeneous heating system throughout the whole reaction mixture. And you can also set up your reaction in the oil bath if you have like safe oil bath, or like metallic bead heating bath. So just to make sure that the heating source is homogeneous. So here 80 degree is attained, so my reaction setup is done. So that's it for today, and if you like the video, please subscribe my channel and stay tuned, and I will bring you a new video. Bye now.